Welcome to our weekly workshop. My name is David Raymond. I'm the director of the Virginia Cyber Range and the U.S. Cyber Range here at Virginia Tech. And welcome to our continuing series of workshops. And we're going to continue our discussion of beginner level CTF challenges. And here's our brief schedule. Last week we talked about reconnaissance challenges, so that video recording should be in our YouTube channel. So go ahead and go to YouTube and then search for Virginia Cyber Range, and you'll find this whole series of recorded videos along with lots of other stuff. This week we're just going to dip our toe into reverse engineering challenges, right? So this is just going to be a very high level introduction to what reverse engineering challenges might look like, and we're going to look at some very entry level reverse engineering challenges. Unfortunately, you don't see a lot of super entry level reverse engineering challenges in CTFs, at least not in the sort of the weekly ones that you can find on CTF time. Most of the sort of weekly collegiate CTFs, if they have a reverse engineering category, it's generally pretty advanced. However, anytime you find kind of an entry level CTF or a practice CTF or something that's set up for high school students, if it has a reverse engineering category, then you'll see the kinds of things that I'm going to talk about today. And so I'm going to just talk about just the basic approaches to some of these beginner level reverse engineering CTF challenges. And sometime later in this series, maybe we'll dive into some more advanced reverse engineering challenges. But today we'll hit the wave tops. So we have a CTF set up for you to practice in, and I've got some reverse engineering challenges in here. So if you go to vacker.io/weekly workshop, you can self-register and play. If you already did that during a previous workshop, then just go to that URL and log back in, and you'll be able to take a look at the challenges that we've got for this week's session. And my disclaimer bullet there at the bottom, you might see challenges added and removed. And that might be true this week too. I don't remember if I added or removed stuff, but some of the challenges in the reverse engineering category might have changed. Okay, so here's reverse engineering in a nutshell. So generally in a reverse engineering challenge, you are going to analyze and or modify an existing program to reveal the flag, whatever the flag is, and we'll see some of those flags today. So generally, you're only provided the binary application, right? You don't get any source code. You just get an executable program. And so if you're not familiar with assembly language programming or with computer architecture, some of this can be a pretty heavy lift, right? So you can imagine that some of these entry-level challenges don't require a background in assembly language programming or in computer organization or computer architecture. But as you advance through the more difficult challenges, it's good to have some familiarity with those things. That doesn't mean you have to have taken college classes in computer organization, right? It just means that you have to have some familiarity with the concepts like registers and CPUs and program counters and things like that. And that's knowledge that you can gain by doing some of these challenges and by watching, things like YouTube videos that talk through some of these reverse engineering challenges. Now, the more that you know about assembly language and computer organization, the better off you are. But some sort of just basic knowledge will get you quite a ways in these kinds of challenges. So I would encourage you to at least take a look at some of these when you see them in future CTFs. Some of the common tools that you might use when you're analyzing these programs are things like object dump. So that's a Linux command line disassembler. So you can take it takes the executable program that is stored as binary values in memory, and it disassembles it. So it'll turn it into assembly language code that you can read, and that is a little bit, it's obviously way easier to read than just the binary program. certainly it's not like reading a C program or a Python program, right? The assembly language is much more difficult to just sort of analyze it and read it. Again, unless you have some background in that very low level language. Another tool that you might use is a debugger like GDB. So GDB stands for the GNU debugger. And so if you've got any programming experience, you probably used a debugger before to debug your programs. What you can do with debuggers like GDB and others is you can actually you can be running a program and you can actually cause the program to take different execution paths, right? So you can if you have an if then statement, you can cause the program to go in one direction or the other if you know how to use these debuggers. And so they're really useful for some of these reverse engineering challenges, because sometimes you just have to get the program to execute down a particular path. And if you can do that in a debugger, then you don't have to necessarily completely analyze the assembly language program. You can just get the program to execute down a particular path, and that can be very helpful. There's a tool called binwalk that is a Linux tool that examines binary images for embedded files. So sometimes you'll have a executable program, a binary program, and it's got multiple things in it, and you can use tools like binwalk to sort of break out those binary images to find embedded files in there. There's a tool called IDA Pro that is a commercial disassembler and decompiler. And I have a picture of IDA Pro on the right side of the screen here. And IDA is really interesting piece of software. It's used widely by malware reverse engineers, right? So people who get paid to reverse engineer malicious software, and the kinds of people who get paid to do that are people who work at security companies. And they reverse engineer malicious software so that they can create signatures for them for antivirus or for intrusion detection systems, or they might be, there's lots of reasons why you'd want to be able to reverse engineer malicious software. And IDA Pro is a commercial software that'll do this. And you can download older versions of IDA Pro for free off the internet, and that's just you can do a little Googling and find how to download this software. It's been very widely used for many years in the industry, in the InfoSec industry. It's pretty expensive so if you're actually going to pay for a license, then it would cost you $3,000 or $4,000. So most like college students who do this, they use a demo version of IDA Pro. So it's maybe an older version, or they have a free demo download, but it's not full featured. It's got the basic features, so you can disassemble the program, and you can even do this thing that I show here on the right side of the screen, right? This is a program that has been disassembled. And so if you were to zoom in a little bit more, you'd be able to see the assembly code here in these blocks. And what IDA Pro also does is it breaks the blocks down into these logical chunks, right? So this chunk of the program executes, and then it goes to this chunk of the program, and then it'll branch. So there's an if-then statement here that'll either go to this chunk of the program or it'll go to this one. And so by having this view, you can see how the program would operate depending on what happens at these different if-then statement points. And you can even in IDA Pro you can debug. So it has an integrated debugger, so you can be debugging live, and you can see the individual statements execute in this view, like right here where this red line is highlighted. So this program is actually executing, and you can see that this is the statement that it's on, and then you can see there's a green line that says this, if the state doesn't change, then this if then statement is going to go to this block, and it's not going to follow this red block. And so it's very useful if you're getting down to the individual instruction level and trying to see how the program operates. Again, great, very useful tool. very expensive if you're going to pay for full freight for all the features, but you can get free demo versions, and this is widely used by CTF players and by professional reverse engineers. Another tool that is gaining popularity, it's relatively newer than IDA Pro, right? IDA Pro has been around for probably 10 or 12 years, and Ghidra is a relatively new tool. But it's the cool thing about Ghidra is it's free and open source, and it was created by the National Security Agency for use by the National Security Agency. So this is a federal, the NSA obviously is they're sort of the paid hackers in the federal government. They both attack and defend from a cybersecurity standpoint, and Ghidra is a Java-based tool that they've built to do reverse engineering of software. And the really cool thing about Ghidra, and I may get to it and show you how you can use it. A really cool thing about Ghidra is that you can not only decompile software in Ghidra, but you can disassemble software for free, right? So if you were to pay for the IDA Pro disassembler, again, that would cost you $3,000 or $4,000. Ghidra does disassembly for free, and you can see the disassembled program as a C program. So if you're a C programmer, it makes it way easier to analyze that software because Ghidra is going to disassemble it for you, and you can see the actual C code, C programming language code used to that was compiled and assembled into the executable program. So I'll try to get to that in a few minutes. But these are the common tools that you'll see if you're doing reverse engineering. And so when you're going through for these entry-level challenges, here are the kinds of things that I do to approach these, the first time I encounter them. It's strings. I think I've talked about strings before in these workshops. Strings is kind of my go-to anytime I have a file and I have no idea what to do with it. I usually use the file command to try to figure out what kind of a file it is. I'll usually use the strings command and then grep that through flag to see if the word flag is embedded somewhere. Those are like easy points if it only takes me a few seconds to do that, and it might be very helpful in me solving a challenge. So always use strings to see if the flag is obvious. And maybe one time out of 50 that'll help you, but that's better than 0 out of 50. The next thing you have to do is you have to figure out what kind of an executable it is, right? So when you download a CTF challenge file, the challenge may or may not tell you if you can run it on a Windows computer or if you can run it on a Linux computer, right? If it just says, figure out, find the flag or whatever, and it's got a file. So it might be, the file might be an ELF file, executable in linkable format. That's a Linux executable program. So it might be that. It might be a PE or a portable executable. That's a Windows program. And you can't run a Windows program on a Linux system, and you cannot run a Linux program on a Windows system, right? So if you use a Linux system to do most of your CTF work, which I personally use a Linux system a lot for this, you got to figure out what kind of an executable program it is before you can run it somewhere. There's also an AIF format, which is an ARM image format. These are for embedded systems. And so that's the thing that doesn't run on a Linux or a Windows system unless you install some specific tools, right? So you can install an emulator on a Linux computer that will execute an ARM image. But you don't know to do that until you know that the program is an ARM executable. And the way you do that, again, is using the file command. So if you say file and then the file name, and we'll take a look at this in a minute, the Linux command line will tell you which of these types of program it is. If you download the program into Windows, that Windows program is generally going to be runnable as soon as you pull it down into Windows, and you can run the Windows program executable. With Linux, it's often not so easy. So when you download the program in Linux, the ELF executable often is not going to be executable, right? It's not going to have the right file permissions to actually execute. So you can try to execute it and it's going to give you like a permission denied error or something like that. And if you recall, file permissions, in order for a program to run, to execute, it has to have an executable file permission. And we'll take a look at that here in a minute. So this is how you make a program executable. You use the chmod command with a plus. There's various ways to do this using the chmod command. The way I usually do it is I say chmod change mode plus X. So that's going to give the program the executable flag and then the file name. And then you run the program to see what it does, right? And then another thing you can do is fuzz the program to see if you can make it fail ungracefully. Like if you can overflow a buffer, for example. And we may get to that here in a few minutes. Okay, so now I'm going to do some hands-on. Any questions as I'm switching to hands-on mode? So I'm here. So I'm on a Linux virtual machine in the Virginia Cyber Range. And this is sort of interesting. I'm using one of our new non-persistent environments. So we just rolled out these non-persistent environments in the Virginia Cyber Range. And these are short-lived environments that you can provision into your class. They've been rolled out both in the Virginia Cyber Range and the US Cyber Range. Some cool functionality around this. They only last for a couple of hours, and then they delete themselves. So every time your students come in to start one of these VMs, they get a brand new environment every time, which is sometimes you want them to have the old stuff that they saved last week or whatever. Often you just want them to have a clean slate, and these non-persistent environments facilitate a clean slate every time the student comes in. They're also way cheaper if you're a US Cyber Range person, because they don't take the storage footprint, and so it's a lot less expensive to maintain these. Okay, so I'm on the reverse engineering challenges here in the CTF. Hopefully we're logged into the CTF and we can take a look at this. And I'm going to take a look at the very first CTF challenge here. It's called strings. And strings, it says run me from the Linux command line. And let's do that. So I'm going to click on strings, and that's the downloadable file here. So if I go to my terminal window, let's see if I can blow this up a little bit. Okay, so I'm going to CD into downloads, and there's strings, right? And so normally to run a program with the command line, I just do /strings, and it should run, right? But it says permission denied, right? I can't run this program. Well, if I use the file command, and I check the file command against strings, this tells me it's an ELF 32-bit executable. And so why doesn't it run? I wonder why it doesn't run. Well, let's take a look at the file permissions. It's called strings, and we'll see that it's not executable, right? So it doesn't have the execute bit set on the file permissions. And I'll let you do research on file permissions on your own if you're not sure what that means. Maybe we'll talk about that in a later workshop. But here the file permissions are read and write for the owner of the file, read and write for the group. I'm sorry, read for the group and read for everyone else. And without this executable flag set, I can't run the program. So I have to use this chmod command. So chmod plus X, that's going to add the executable flag. And the name of the program is strings. And so now I did that. And if I do my long listing, I see that now I have the executable flag set. So now I should be able to execute the program. /strings. And okay, now it runs, but it doesn't do anything. This is not the flag. Okay, so what do I do next? Well, this is a 5-point challenge, and so it's bound to not be very difficult. So it's called strings. That might be a hint. So what I'm going to do is I'm going to run strings against strings. So I'm running the Linux strings utility against this program in the current directory called strings. and I get a bunch of strings that fall out of this thing. And if I scroll up here, here's me running the strings command, and here's the output. So I could have also run this through grep. Right, so I say, oops, grep flag. Okay, so I run the strings command against the strings executable that's in my current directory, and then I pipe that through grep, and I'm searching for the word flag, and what I get is every instance of the word, every line that has the word flag in it, and so here's the flag, right? We're all following along here. So if I paste that in here, then that should give me my points. There we go. I got 5 points. Okay, the next one is really easy. I'm not even going to do it. It just says run me in Linux, and you'll see if you're able to run this and make it work, then it's gonna give you the flag. The next one I want to look at is I want to take a look at this one called buffer overflow. And I'm actually going to switch to my Windows system for this, because I'm going to throw this into Ghidra, and I'm going to show you what that looks like. So here's buffer overflow, and I'm going to download the program, and now I'm going to go to my Linux terminal for Windows. So here I'm on Windows 11, but I'm running a Linux terminal. And if you don't know how to do that, then Google running a Linux terminal on Windows, and it's pretty straightforward to set up. But if I do my list, here's my program called buffer overflow 1. And if I do a listing, here's buffer overflow, and it looks like in this case the executable flag is already set. So now I can just run the program buffer overflow, and it's going to ask me for a password, and that wasn't the password. Okay, so there's this particular program. There's multiple ways to solve it. We'll take a look at some of those ways to solve it. But what I want to show you really quickly is I'm going to show you when I throw this in this software called Ghidra, and we'll see what happens when I do that. And I have let's see. I have Ghidra here, and I'm going to run it. Close. So to get Ghidra, I have the Ghidra webpage up here. So if you just Google for Ghidra, you're going to get this page. It's ghidra-sre.org. This is the Ghidra webpage, and it's got lots of useful resources on how to use Ghidra, and it's got a link to the download, so you can download it from GitHub, and there are lots of versions of it, and you want to download the latest version. When you download it, you're just going to get a zipped folder with Ghidra in it, and the way you run it is, what I just did was I opened the folder, and there's this batch file. That's the old days of Windows command line, right? We use batch files to run stuff. Well, that's how Ghidra works. It's a Java executable, and you just run this batch file. I double clicked on it to run it, and that starts up Ghidra. And so what I'm going to do here is I'm going to create a new project, and I'm going to call it CTF. And now I have a new project called CTF. Okay, the next thing I'm going to do is I'm going to go to my downloads folder. This is buffer overflow 1, and I'm just going to drag it in here. And it's importing the program. So here's a summary, tells me all about it, right? It's called buffer overflow 1. It's an ELF executable. So it tells me it's a Linux, x86 Linux executable compiled with GCC. Lots of good info here. I can click OK, and now I can double click that to open it up, Now it's going to open another window. And it asks me if I want to analyze the program. I'm going to go ahead and analyze it. There's a bunch of options, and I'm just going to take the defaults. And so now what I see here in Ghidra is this is the disassembled program. So this is assembly language, and assembly language is I wouldn't say it's not human readable, but it's fairly nonsensical unless you know assembly language programming. And so I'm not going to teach you that here. But over here I have there's a decompiler window. That's the really interesting bit of this. And for a C program, this is a C program. Almost every program you see is going to be a C program, you know, that you're reverse engineering. And I'm going to direct your attention over here to the left. There's a section that says symbol tree, and there's a functions area. And a C program always starts with the main. There's a main function, and a C program always starts with main, right? So I'm gonna find the main function here, and when I click on main, what I see is the disassembled main, right? So this is assembly language for the main function. Over here on the right, I have the decompiled version of that. So this is actually C programming. This is the program in the C programming language. So it looks like what it's doing is it is creating a variable here, and Ghidra just gives it a variable name because variable names don't come along when the program is compiled. So it calls it local 56, and it's a character array with 82 characters in it. So it's an array of 82 characters. So it's kind of interesting. Then it does this printf. It says enter password. So remember when I executed the program, that's what it did, right? When I ran it, it's enter password. And that's this line right here being executed, enter password. And then it does this thing called a get s. So it's going to get whatever I type in. And so I type something in for password, and you see what I got was this thing called access denied. So it does this get s, so it accepts my input, and then there's a function called check_pw. Check_pw. Okay, well, what I think that probably means is check password, right? So what this program does is it accepts, it prints out a message, enter password, then it accepts the password that I type in, then it's going to run this function called check password, and then that's the end of the program. Okay, well, I can click here and I can go to that check password function, and here's the whole function. And again, it's in C. So here's what that function does. It creates an integer variable, and then it does this string compare, and it compares parameter 1, which is the parameter that's passed into the function. And the parameter that's passed into the function is that, if I go back to main here, the parameter that's passed in is local 56, which is the thing that I typed in at the command line, right? So it's this character array. Okay, so the character array is passed to the check PW. And so now the check PW is going to compare that value with this string, $3CR3T. Well, that's interesting. What happens if I type that in now at the command line as the password? Buffer overflow 1, enter password, $3 secret. Well, look at that. Access granted, right? So that was the answer. That's the password. And here's the output and the challenge text. If you read the challenge text, it says, get to the right tab here. It says the flag is the last name of the author quoted. Okay, so the flag is the last name of the author quoted timeline. I'm not done with Ghidra yet though, so I'm going to go back to Ghidra. So that's interesting, right? This was quite straightforward when I pulled it into Ghidra and disassembled it. I was able to discover what the password was, so I could run the program, put in the password, and got the right answer. Okay, well, what if it didn't do that? What if it wasn't so simple, right? what if this was somehow obscured in a way that I couldn't just type it in at the command line? Okay, now I need to look at more of the program. So this check PW program, it compares what I typed in to the past to this string literal, and then it does one of two things. It either calls the access granted function or it calls the access denied function. Okay, well, you can imagine what happens when it calls the access denied function. It prints out access denied, and then the program exits. And that's what happened, right, when I put in the wrong passwords. If I go back to main though, and I go to check PW, and I go, instead of going to access denied, if I go to access granted, okay, here's that function. And if I look at that function, here is the output that I got when I put in the correct password, right? So progress isn't made by early risers, it's made by lazy Ben trying to find easy ways to do something. And there's the answer again, right? So there was two different ways using Ghidra to solve this challenge in a very straightforward way. There are multiple other ways to solve this challenge that I'm not going to talk about right now because we're out of time. One of the ways is to do a buffer overflow, right? And that's what the title of the challenge is really directing you towards. But it's way easier than that if you just pull this into a tool like this. Very powerful tool for analyzing software. And there's also a debugger in here, so I could run the program and cause it to take a specific execution path if I wanted to do that. Ghidra also has this tool that, like what I showed you in IDA Pro, where it'll show you the program, it'll show you the possible execution paths of the program. This function isn't very interesting. There are no if thens or anything, so it only shows one box. If I were to look at the check PW function, it would be a little bit more interesting because at least there's this if then, so it'll do one of these two different things, and then it'll come back. All right, so I'm going to stop there and let me throw up my slide one more time. The challenge, and these are Cloud CTF resources. We have lots of knowledge-based articles on the CTF. We have lots of videos on our YouTube channel. And if you need customer support, then please just send an email to support@virginiacyberrange.org or support@uscyberrange.org. And I'm going to stop there. So any questions or comments before we wrap up? All right, thanks. Next time we will talk about something else to be determined. So we look forward to seeing you next time. We'll continue along the theme of capture the flag. All right, so thanks and see you next time.